What a nice smile. All right, so anyway, as I was saying, 1 mole of anything is 6.02 times 10 to the 23rd of that thing. Each individual element, since they weigh different amounts, just like if you got a dozen bagels and a dozen eggs, they don't weigh the same amounts, even though you have the same number of those things, since they weigh different amounts and their masses are different, even though you have the same number. So for 1 mole of anything, each mass is individual to a particular atom. So as I said, oxygen is 16, carbon is 12 grams, and that's how many grams you'd weigh out to measure out 1 mole of that stuff. You don't ever individually count these atoms. When we talked about moles a long time ago, I told you that this would take forever to count, right? Even if you're the fastest supercomputer in the world, it would take you thousands of years to count to this number. So we're never going to count them individually. So what we do in lab is we measure out, if I say you need to have 0.5 moles or something like that, you measure that mass amount in grams, which is a lot easier. Okay, and that's how molar mass works on the periodic table. It's the red number, and that's the red number in grams. We call that molar mass. Sometimes it's called molecular mass. But we basically dealt with one atom, and today we're going to look at how it works for a compound, which I think is pretty intuitive and self-explanatory. So sometimes called molecular mass. Just as an example, 1 mole of sodium equals 23 grams. Remember I said a long time ago you can round these if they're really obvious. So like if you look at sodium and it says 22.99 something, go ahead and round that to 23. Carbon is 12.01 something, go ahead and round it to 12.
What would you do for...
But the ones in the middle, keep them in the middle. For example, chlorine is 35 and a half or 35.45. Keep that in the middle. Or magnesium is 24.3, is that right?
How about bismuth?
What about thulium?
Okay, I don't know all the ones. I'm just saying that the ones that are in the middle, that are not 0.01 or 0.99, keep them where they are, round to the nearest 10 or 100 place. But don't.
So like a 7 would be like gallium is 69.72, you want it to be 69.7.
I would just leave it at that, yeah. Okay. There'll be little changes based on how you round, but just try and keep it consistent. Okay, so that's the molar mass of one thing. To find the molar mass of a compound, you do exactly what you think you do. You just add up the molar masses. So for example, I want to find the molar mass of sodium chloride. All that you do is you add up the individual amounts for each element. So for example, sodium, as we just said, was 23 grams. And then you add the molar mass for chlorine, which I also just said was 35 and a half. And so the molar mass of sodium chloride, which is a compound, is going to be 58.5 grams. It's pretty easy, right? We're not done yet, though. Because there's other, formulas can get more complicated. And so if it was, I don't know, you're going to tell me some of these in a second, like if it was MgF2, magnesium fluoride, which just make you all name these. You still do what you think you do. It's 1 magnesium and 2 fluorine, so you need to multiply a little bit. Magnesium is what? That's the 24.3, right?
4.3.
And then fluorine is what, 19?
Yep.
But you take that 19 grams and you multiply it by 2, because there's 2 fluorines. Okay,
Well, 62.3.
and the whole total is what?
62.3.
62.3 grams.
Oh.
Now, when you say this, you should say grams per mole. I just messed that up. So the form or the units on molecular mass are grams per mole, because it literally means how many grams are in 1 mole of that compound. Also, in each of these, remember that the molar mass is equal to this number too. So this is how many atoms or molecules or particles are in that amount for each of those. Yeah.
Well, how does 24 plus 19 equal 62?
It's 20 times 2.
Oh, times 2. I thought it was 19.2. You idiot.
Where else do formulas get more complicated? What else can you involve in them? Parentheses, right? And so if you have something like, I don't know, let's not do magnesium anymore, let's do barium.
I love barium.
Barium nitrate, I should make you write all these, wouldn't that be fun?
No, I wouldn't.
You should do ammonium.
Hey, can we do this? The yellow sheet stuff?
Yeah. Oh, yeah.
Like hydro.
Yeah, well, that's what we're doing now.
Oh, I know.
Anyway, so when you have to add up all these elements individually. So barium is the easy one. Add up, I don't know what barium is though.
137.13.
37.3 grams. And then this too gets distributed to everything in there. So if there's 1 nitrogen, it's really times 2. So you'd say 2 times nitrogen. And then there's 3 oxygens, but you multiply it by 2, so there's 6 oxygens. Make sense? So 2, it's just like a math problem. It gets distributed into whatever's in the parentheses. So we say nitrogen is 14 times 2. 14 grams times 2, plus 6 times, and then 16 for oxygen, 6 times 16 grams for oxygen.
96.
And then you add them all up to get the molar mass. And that would be something that Tori will hopefully tell us in a second.
96 plus 28. That's 96 plus 28.
Plus 1.7.3.
Yeah.
Yeah. 290,
250.
50,
261.3.
261.3
Did you do that in your head?
grams per mole.
Yep.
He actually did it in my head.
Yeah.
Where does those 16?
Oh, that's the molar mass of oxygen. That was weird.
Oh, okay.
That's the molar mass of oxygen.
That's
So, if you can't see here, here's the barium, here's the nitrogen, here's the oxygen. We're just adding all of those together, that's all.
You get a taco bar and tear it
All of a sudden, sounds like my freshman class. What else is it on this worksheet? I would you do in a second.
Oh,
No work here.
Oh, the
Nothing,
last
it's
thing,
not a worksheet.
sometimes compounds have waters attached to them, and so you'll see every once in a while something like, I don't know, what's this called, you know?
Aluminum hydroxide.
Aluminum hydroxide, very good.
you totally.
Sometimes they have waters attached to them as part of their formula, and there's a giant dot, and then this one will make up says 5 waters attached to it. Okay. And so this works exactly the same as how you think it would. You add up the aluminum, and I'll just do it right here. The aluminum was what, 27 grams of
Yes.
aluminum?
Do they stick together with hydrogen bonding?
This does.
The waters, yeah.
They kind of get trapped inside the molecule, inside the crystal structure,
Okay.
and so it's kind of attached to it.
And 16.
Oxygen is 16 times what?
3.
Times 3, because there's 3 of them. One distribute, there's 3. Hydrogen is 1,
Yeah.
so 1 times 3.
3.
And then you also add these 5 waters.
You
So
add or
say-
multiply?
You add them. Water is just, I mean, if you want to do it the easy way, instead of like doing the individual elements, water is just 18 grams, because it's 2 hydrogens plus 1 oxygen, so essentially 2 plus 16. So you could just say 18 for this whole thing. That makes sense.
18 times 5.
So you just do 18 times 5, so plus 18 times 5.
Oh.
So some of these just have waters attached to them, and you don't, it's not going to change anything for
90
you, but.
plus 93.
And as a matter of fact, we don't do them very often here, but this works.
3 plus 27 is 120. What's 16 times 3?
What's that?
48.
That's right.
Yes, it is.
168 grams per mole.
Yes, right.
So if I needed a mole of this stuff for a particular reaction, you just go to the lab and do this first, and then good. See, now, where we're gonna intersect, and you can see the trouble on the horizon. For those of you who, well, we haven't looked at the test yet, and I won't look at them this weekend probably because it's very busy, but you don't care about that. But the problem's gonna be when we start having to name these first, or if I gave you this name, if I said to write this, and then you did something like, whatever, just not correct, and then you calculated the molar mass, and then you did another part of the problem with it. So that's why, as I mentioned several times, naming will never really go away. We'll always use it. So writing the formulas is very important. Yeah.
So that giant dot with the waters,
Yes.
so the giant dot just means addition.
This just means plus 5 waters attached to it. Yeah. Well, don't multiply by
So
5.
giant dot just means plus.
Yes. Plus 5 waters.
Plus 5.
It's not difficult, yes. The challenging part will be when we start doing math in addition to this. This will be like the first thing you do, and then there's a bunch more math that goes along with it. Right? Chemistry, right, you guys? Which we'll probably do on Monday, because we're trying to,
Nothing else to do.
10 times 5.
right now?
Yeah.
Okay, we're done.